QuantWare pitches a bold leap in quantum hardware with a 10,000 qubit target in a 3D expanded VO40K architecture. In contrast, Google and IBM continue to chase higher qubit counts as the industry's near-term benchmark. Willow's 105 qubits and IBM's 156 qubit Heron are what today's mainstream processors offer in the race for practical quantum advantage. QuantWare's approach shifts focus from mere qubit counts to scalable, low-loss interconnects and modular chiplets. The 40K in VO40K refers not to 40,000 qubits, but to 40,000 I/O channels that enable rapid scaling. QuantWare mounts a modular design where chiplets talk through high-fidelity interconnects to bypass traditional single-chip routing limits. This architecture promises better energy efficiency and cost per swan-li than current multi-QPU networks. QuantWare emphasizes an open standard so any superconducting qubit team can build atop the VIO framework. Productization remains for 2028. With first public samples expected in the mid-late decade. QuantWare's KiloFab in Delft is planned to scale manufacturing to meet demand, 5 times the current output. Q-Tech and TU Delft's pedigree anchors QuantWare's story as a spin-out that became a hardware supplier, not a system integrator. Founders Matt Ray-Larestam and Alessandro Bruno leveraged their deep expertise to pivot toward modular, scalable quantum hardware. Unlike Google's vertical integration, QuantWare positions itself as an Intel-like supplier for the quantum era. Their business model targets chip design and foundry services while leaving end systems to customers. Investment rounds totaled several million euros, backing a plan to democratize access to quantum hardware. By aligning with NVIDIA's NVLink, QuantWare enables quantum classical hybrid workflows with Q-to-Q scheduling. The ecosystem also includes a quantum utility block to help organizations deploy local quantum systems quickly. QuantWare's reference design, created with QKetrel and QBlocks, targets enterprises seeking ready-made quantum stacks. Elevate Quantum collaborates on deploying QUB systems in Colorado, illustrating real-world pilot deployments. QuantWare's 2023-2024 funding rounds drew support from European and Dutch tech funds to accelerate growth. Global customers span Yongu institutes and industry labs, signaling broad adoption beyond Silicon Valley hype. The key question remains whether 10,000 physical qubits can be turned into useful, fault-tolerant logical qubits. Experts note that error rates, gate fidelity, and noise management are the real bottlenecks in scaling quantum systems. Google's approach emphasizes error correction thresholds and longer coherence times to push practical capability forward. IBM's roadmap continues to place 150 qubits as a mainstream baseline well into 2028. Despite the hype, the industry recognizes that more qubits do not automatically equal practical compute power. QuantWare's VIO40K stance redefines the debate by arguing scale can be achieved via architecture, not just more qubits. NVIDIA's NVLink partnership positions the company at the intersection of quantum and classical high-performance computing. QuantWare remains cautious, noting that KiloFab's ramp in chip yield will determine real-world viability. Industry watchers compare the 10,000 qubit target to the earlier threshold milestone Google touted in 2019. In this evolving landscape, the practical path may hinge on ecosystem openness and multiple suppliers contributing to a quantum stack. QuantWare's ambition is to become the industry's Intel, supplying core hardware to enable broader quantum software ecosystems. Together with QUB and KiloFab, the company aims to shorten the path from chip design to deployable quantum systems. With a 2026 KiloFab start and 2028 chip deliveries, QuantWare sketches a longer race with tangible milestones. The broader takeaway, the quantum industry is testing multiple routes towards scalable, fault-tolerant computation.